Hello, welcome to a new episode. Today's topic is the multiclass regression part 1. We'll be talking about how to fit the coefficients of the multiclass regression. The main objective is to extend the logistic regression to allow for multiclass in the dependent variable y. In order to do so, we'll implement the method called 1 versus all. There's a prerequisite for this video. Please watch the previous episodes on the logistic regression, at least the first one of the series. The basic assumptions are, we have a number of independent variables. They are usually denoted as x1, x2, and so on. And there is one dependent variable denoted as y, of which values can be 0, 1, 2, up to a maximum. In order to implement the method 1 versus all, we should partition the possible values of y in the following way. On one side, you have one possible value, and on another side, you have all the rest. For example, you have 0 on the left and all the rest on the right. You have 1 on the left and all the rest on the right, and so on. So the idea is to do simple logistic regression with y, which is again binary, 1 or the rest. And repeat this for all the partitions. Okay, now it's time to go through an example. The data for the example comes from the iris flower data by Ronald Fisher. It was published in 1936. This data set has 4 independent variables and 1 dependent variable, which is the species label. There are 3 different species with 50 observations or rows in each. This makes 150 observations or rows in total. The columns x1 through x4 are the independent variables. They correspond to the different measures of the iris flower. Y column has the species label 0, 1, and 2. We have this Excel file named Example Multinomial Logistic Regression Fit. As we can see, we have the columns representing the variables. Now, let's fit the coefficients using PrimaXL. We go to the PrimaXL tab, then Multi, and select Fit. This menu form is quite easy to understand. At the top, we should specify the data range of the independent variables. Next, we should specify the data range of the dependent variable y. Then finally, we should specify where to output the result. Okay, let's just do it. Okay, I think we are ready. Now just press the Run button. Great, we have the result. Let's interpret the result. We have this result output. At the top, we have 0 versus all the rest. Then we have 1 versus all the rest. Finally, we have 2 versus all the rest. In the very first column, we have the coefficient labels. In the second column, we have the coefficient values. Then, in the third column, we have the corresponding errors. In the next column, we have the z-statistics, which are calculated by dividing the coefficient value by the error. In the last column, we have the p-values. The p-value is such that the smaller it is, the more statistically significant the coefficient is. Usually, when the p-value is smaller than 0.05, we say that the corresponding coefficient is statistically significant. Finally, a summary. Today we saw how to fit the regression coefficients when there are more than two categories or classes for the dependent variable. We used the method called 1 versus all. Then we discussed about the p-values and the statistical significance. In the coming episodes, we'll cover the following topics: forecast using multiclass regression, test using the multiclass regression. Excellent! I hope you enjoyed watching this video. Thank you so much. Until next time, bye.